Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for students in MCF 3M, and it's a video where I'll take up the practice questions for the summative. This video is for question number 1. Here's the question. It says, the sticker warehouse sells rolls of stickers for $4 each. The average customer buys 6 rolls of stickers. The owner finds that for every 25-cent decrease in price, the average customer buys an additional roll. The revenue per customer is this formula, where X is the number of times that the price is decreased by 25 cents. And then we have some questions to answer. What is the maximum possible revenue? How many rolls of stickers and at what price? And how many price reductions will have to occur for the revenue to be $30? So let's start by just looking carefully at the formula. So we know that this is a formula that looks at revenue based on X. Now X is the number of price decreases. So right now we know that we are selling sticker rolls for $4 each, but we might decrease the price by 25 cents or 50 cents or 75 cents or some multiple of 25 cents. We don't know, that's what the X is, because we don't know how many times we're going to decrease the price. Now we know that when we decrease the price, we're more likely to sell sticker rolls. Right now, we sell 6 sticker rolls, but when we decrease the price, we increase the number that we sold. And so this formula represents the relationship between X, the number of price decreases, and the overall revenue. So when I look at this formula, obviously the most important thing, other than understanding the variables, is that this is a factored quadratic. So it is a quadratic because if I were to multiply this out, I would definitely see x squared and nothing more complicated than x squared. If you imagine doing FOIL on it, you would get a nice normal standard form quadratic. But this is in factored form. So I'm going to do as much as I can by leaving this in factored form and see how far I can get. So let's look now specifically at what we have to answer. Well, one thing we have to do is find the maximum possible revenue. So again, revenue is here. It's where y would be if this was just a pure algebra question with x and y. And we want to maximize the revenue. Now, in the world of quadratics, whenever you see the word maximum, you should obviously think of the word vertex. I want to be able to find the vertex. If I can find the vertex, I'll be able to answer any question about the maximum or minimum. In this case, it's a maximum. It can't be both. A quadratic that looks like this has a maximum, and a quadratic that looks like this has a minimum. And so this is a quadratic that looks like this. It has a maximum. So we need to find the vertex in order to talk about the maximum. So if we have a factored quadratic, the easiest way to find the vertex is to find the roots. And the roots are the also called zeros or the x-intercepts. The roots are the values that make each of these brackets 0. So if I can figure out what x value makes this whole bracket 0, I have one of my roots, and then find what x value makes this bracket 0. That would give me my 2 roots. Now, why are the roots important? Well, if we find the midpoint of the roots, we are finding the x coordinate that represents the vertex. So we're also finding where the axis of symmetry is. So if we find the midpoint of the roots, we'll have half of the vertex. We'll have the x coordinate, the part that goes here, and then we can find the rest of the vertex by subbing in that midpoint number to the original equation. Because when we sub the midpoint back in for these x values, the result will be a value for r, which is the rest of the vertex, or the value that goes here. So in order to find the maximum, I know I'm looking for the vertex. And in factored form, the easiest way to find the vertex is by finding the roots, taking the midpoint of the roots, and then subbing that in. So that's how we're going to do part A. Part B says how many rolls of stickers and at what price. And so obviously that's connected to question A. We're looking for at the maximum. So when we maximize the revenue, how many rolls of stickers will we sell and what will the price be? So again, if I look at this equation and remembering the question, we knew that right now it was $4 per sticker and we were going to decrease by 25 cents for every X, which means this first bracket represents the price of the stickers. And how many rolls of stickers? Well, right now it's 6 rolls of stickers, but we're going to sell 1 more for every X. So this bracket represents the number of rolls of stickers. So once I solve for X in the vertex, which we'll do in part A by finding the midpoint of the roots, if I sub that X value into this bracket, I'll know the price. And if I sub that X value into this bracket, I'll know how many rolls of stickers. So by doing question A, I've done almost all the math I need to do part B. So what else do we have to do? It then says how many price reductions will have to occur for the revenue per customer to be $30. So when it says how many price reductions, remember that's asking me to find X, because that's what X represents, the number of price reductions. So I know that I need to find X. And what I'm told is to find X when the revenue is $30. So to solve this one, I need to sub $30 for the revenue. So I still don't know X. That's what the whole point of this particular part of the question is, to solve for X. So now I have this equation where I know the revenue is 30 and I don't know X. So how am I going to solve for this? Well, even though it still looks like factored form, it's not valid in factored form unless you have equals 0 on this side, or just the y value or the y coordinate. So because I have a number over here, I can't use the same thing I did before, which is just simply look at the roots. So what I have to do is I have to do a bunch of algebra. So what we would need to do is to actually multiply these two factored brackets together using FOIL. So I'm just going to start that process. 4 times 6 is 24. 4 times x is positive 4x. Negative 0.25x times 6 is negative 1.5x. And then negative 0.25 times positive x is negative 0.25x squared. And then if I now subtract 30 from both sides, in other words, you might call that moving 30 over, I'll have 0 equals. And once I have 0 equals, I'm ready to start considering what else to do. So I'm not gonna do too much more math at the moment, but this is what I would get. Now, once I've subtracted 30, so there's my minus 30, so it was here. Subtract 30 for 0, and there's subtract 30 to balance. If I collect like terms, I'll have an equation in the form ax squared plus bx plus c equals 0. And if I want to solve for x in an equation like this, I could try factoring again, but I'm not going to. I would use the quadratic formula. In the quadratic formula, I'll be able to solve for x and tell you what value of x, in other words, how many price reductions, will give me that value of 30 for the revenue. So here's what I want you to do. At this point, I've told you the mathematical thinking process as to how you're going to answer A, B, and C of this question. So my suggestion is, if you haven't already been able to do it, pause the video here and do that math right now. Pen, paper, calculator, actually do the math. It's the best way to learn. And then replay the video when you've got your answers and compare them to mine. So let's actually do the math now. What is the maximum possible revenue per customer? So remember that maximum means we want the vertex, and because we have a factored form equation, we're going to find the roots to find the vertex. So to find the roots, I let y equals 0. Now it's not y, it's rx, but it's where the y would be in an algebra question. But if the revenue was 0, I would be finding my x-intercepts, which are the roots. So now I have 0 equals this bracket times this bracket. So I know that if this bracket was equal to 0, the whole equation would be equal to 0. Because, as you know, anything times 0 is still 0. So if I figure out what x value makes this bracket 0, I have a root. So I'm going to solve for this little equation right here. So I'm going to add 0.25x to both sides, divide both sides by 0.25 to isolate the x, and I have 8. Nope, I have 16, sorry. I should look at my work. 16 equals x. So therefore, I know that one of my roots is at 16, 0. So now let's do the same thing. If I plug 16 here, this bracket's 0. And even though this bracket is like 6 plus 16, 22, it doesn't matter. 0 times 22 is 0. So that's one possible root. And the other possible root would be if I made this bracket 0 instead. So if I make that bracket 0, that means x must be negative 6. So if I sub negative 6 here, I've made this bracket 0. And if this bracket's 0, it's 0 times whatever that is, which is still 0. So my other root is at negative 6, 0. So I now have the two roots of this quadratic. And now that I have the roots, we remember that in every quadratic, we have a line of symmetry. And that line of symmetry passes through the vertex. So if I have a root over here at 16 and another root over here at negative 6, halfway between them will be this axis of symmetry, and therefore the vertex. So let's figure out what halfway between, or the midpoint, of 16 and negative 6 is. So we add them together and divide by 2. You're basically finding the average. So that's 10 over 2, so that's 5. So now I know that my vertex is at 5 comma something. So the x-coordinate of my vertex is that midpoint, which is 5. And now that I know that the vertex exists when x equals 5, I can now go back to the original equation and sub 5 in and calculate what the revenue is. So let's go ahead and do that. So we have the revenue at 5 price changes is 4 minus 0.25x, but of course now we want to use a particular x value, 5, so I'm going to do that substitution. And the second bracket is 6 plus x, but as well, we now know that x is 5. And I know my 5s look like s's. That's why I try to avoid the variable s. It's especially hard when I'm writing on a tablet. So now I'm just going to do this math. So 4 minus 0.25 times 5, that gives me 2.75. And here, that gives me 11. Oops. Sorry. So this is 11. And then if I multiply them together, I have 30.25. So that tells me that my vertex is here. And if I now, again, reconnect that back to the equation, this is x, and this is revenue at x. So when the question says, what is the maximum possible revenue? The maximum possible revenue is right here. It's $30.25. That is the most revenue I can make based on the sticker price that we know about. So let's look at the next question. How many rolls of stickers and at what price? So this is to get the maximum revenue. So we know that the maximum revenue of $30.25 occurs when x equals 5. So if I want to know how many rolls of stickers at maximum, this is the bracket that represents the number of rolls of stickers. And if you're confused as to why, if you go back to the actual question, hold on, I'm going all the way back, it's important. We know that originally it was 6 rolls that people were buying. And so the 6 represents the 6 rolls that people were buying. And then the plus x, because it was 1 additional roll, well, that's 1x. So this bracket is the one that represents the 6 rolls of stickers originally. The other bracket, where you see the $4 each and then 25 cents decrease, that must represent the price. So where were we? We were here. So when x equals 5, the number of stickers is 6 plus 5 is 11. So 11 rolls of stickers is what gives us the maximum revenue. And then at what price? So this bracket is the one that represents the price of the stickers. And again, originally it was $4 per sticker. And now it's some difference because we know that x is 5. So let's calculate what it is. And yes, you probably are noticing I already did this math in the last, on the last slide to answer the original question, but it doesn't hurt to recalculate here. So if I do this math, I get $2.75. So at a price of $2.75, we will sell 11 rolls of stickers, and that is how we got our maximum revenue. Yay. Okay. So the last part of this question says how many price reductions will have to occur for the revenue per customer to be $30? So as I said earlier, I know that the revenue is $30. So instead of saying an unknown revenue, I now know that I want the revenue to be $30. What I don't know is how many price reductions will give me that answer. And of course, price reductions is what our variable x will tell us. So I've turned a algebra word problem, oops, getting weird lines on my screen. I've turned an algebra word problem now into just straight up algebra, which is where we want to find what x makes this equation equal to 30. And so as I said before, every method we have in order to find, solve for x in a quadratic, involves first making it equal to 0. So that's what I'm going to have to do. I'm going to have to do some math to make this equal to 0. So, which means I have to expand that binomial. I like to use FOIL, and then go from there. So when I expand the binomial, I get 24 plus 4x minus 1.5x minus 0.25x squared. And then I'm going to subtract 30 from both sides because that will put 30 over here, 0 over here. And then, so I know I already did this earlier, but it's good to double check everything. So now it equals 0, but the part on the right doesn't quite look like a nice quadratic. So I'm going to collect like terms and put it in the proper order. So the proper order is that we like our quadratics to start with x squared. So the only x squared part is right there, which means I'm going to start with negative 0.25x squared. Then comes the x term. So I've got positive 4x subtract 1.5x. So 4 minus 1.5 is 2.5x. And then the constant term. So I have 24 minus 30. So 24 minus 30 is negative 6. And now I have a quadratic in the form ax squared plus bx plus c equals 0. And when I have a quadratic in that form, it's standard form. And the easiest way to solve for x when it's in standard form is to use the quadratic equation. So the quadratic equation, come on, you know it, you love it. X equals negative b plus or minus the square root of b. Ooh, it's hard with a tablet to get this lined up right. Let's try that again. Square root of b, oh, forget it, it's fine, right? B squared minus 4ac, all divided by 2a. So, I mean, if you haven't had me as a teacher before, you may not sort of, maybe like, wait, what did you write? When I say a formula out loud, any place that I know I have to substitute in a value, I leave an empty bracket. So again, it was negative b plus or minus the square root of b squared minus 4ac all over 2a. So you should see that. It's just where those letters are empty brackets. Just a couple other really quick things. I'd say picky, but I mean important. The square root sign, make sure that you don't like draw part of a square root sign and then get yourself confused. Same with the fraction line. The fraction line should be the whole business. So now I'm going to substitute the values of a, b, and c into this. Now this is going to be tough with, okay, so this was negative b plus or minus the square root of b squared minus 4ac all over 2a. Oops. Now it looks kind of really messy, messier than normal, and that's just because it's really hard to find where those brackets are when I don't see where my cursor is. But you should see that I have negative b plus or minus the square root of b squared minus 4ac all over 2a. And now I just have to calculate that. So my suggestion for calculating it is to do it in the following pieces. So obviously you have your calculator in front of you. So what we do, so first out front here, just deal with that bracket. So I have negative 2.5. Then I'm going to put the line. Now on the bottom, if I do that math, I have negative 0.5. And then I'm going to calculate everything under the square root sign all at once in my calculator. B squared minus 4 times A times C. Now, make sure that you understand how to use brackets on your calculator so that you're not thinking that you're calculating it all at once, but actually making some pretty ugly errors. So B squared minus 4AC, and then I'm going to take the square root. Boy, it's hard to line myself up here. Yay! And what you get is that the square root of B squared minus 4C is plus or minus 0.5. Sorry, that's my cat stepping on the keyboard. So now I just have to finish the calculations. So I have two possible answers. One is x is negative 2.5 plus 0.5 divided by negative 0.5. And the other is x is negative 2.5 minus 0.5 divided by negative 0.5. So if you calculate those, here I get that x is equal to 4, and here I get that x is equal to 6. Now there's two answers, and they're both completely valid. And it should sort of make sense if you remember that the vertex was at 5 and slightly over $30. So if I want $30, I just have to be pretty close to the vertex. So 4 price changes and 6 price changes, well, those are obviously both really close to the vertex because the revenue of $30 is really close to the maximum. So my answer is that if I do 4 or 6 price changes, 4 or 6 price changes results in a revenue of $30. So I hope that was helpful and useful. Think about the skills we just discussed. How do you deal with a factored quadratic, and what can you find quickly, the roots, and what can you do with the roots? Well, just about anything, like find the vertex. However, with a factored form, if I want to find anything other than the roots or the vertex, I have to sub in and do more algebra. But we know how to do that algebra, so I hope that was helpful. Good luck with your studying.